Okay, let's take a look at how we can use trigonometry to solve word problems using two concepts or two words, angle of elevation and angle of depression. Now, some of this may seem a little bit complicated at the beginning. It'll get simpler as we use the words and you see them in action. So first, let's get some definitions. The angle of elevation, if the object is above the observer, the angle between the horizontal line and the line from the object to the observer's eye, that's the angle of elevation. The angle of depression is if the object is below the observer. Okay, if the object is below the observer, the angle between the horizontal and the line from the object to the observer's eye, also known as the line of sight, that's the angle of depression. The relationship between the two is that the angle of elevation and the angle of depression are congruent. The difference is where we are observing from, and you'll see how to use that to figure out all sorts of different lengths or distances, and sometimes we can figure out the angle, what the angle is if we know the lengths and distances. Okay? If you need to pause it right here to get all the definitions down, go ahead and do that. I'm going to move on so we can start working with number one. The big key with this is that we have to understand that we're still using SOHCAHTOA. Okay? We're still using these trig relationships that we used on 7a. We're just going to apply them to concepts now that are word problems. Now, I am a terrible drawer, as I am about to demonstrate right now, but you don't have to be a really good drawer to do this. You have to be able to set up some sort of drawing, though. It just helps. Some students will draw all of these as triangles. Some students who are more artistic will actually draw flagpoles and trees and things like that. Like I said, I'm a fairly awful drawer, but I can do a good enough job that I can see what I'm doing. So for this first problem, the angle of elevation of the sun measures 70 degrees. A flagpole casts a shadow 15 feet long. Find the height of the pole. So I'm going to draw my flagpole. Okay. I'm going to put the sun up here because the sun is in the sky. And then here's the shadow. The shadow is 15 feet long. And it told us that this angle right here is 70. And we want to know the height of the pole. Okay, so now I've set up my drawing. The next thing I have to do, that I'm going to do every time, is if I'm working with this angle, I know that's the hypotenuse. Okay, I know this is the opposite side, and that's the adjacent side. From there, I'm going to set up my trig ratio. I don't have any h, so I know I'm using tangent. So the tangent of 70 equals h for height over 15. From here, you just got to get out your calculator. You got to put in the trig functions appropriately. My calculator, every time I turn it on, thinks that it's brand new, so I have to go in and change it and make sure that I'm in degrees. Once I do that, I can go ahead and the problem is the tangent of 70 times 15. So tangent 70 times 15. And my answer is, the directions say around to the 10th, so my answer is 41.2 feet. And that's it. Let's take a look at number two. A man at the top of a watchtower knows that his eye is 86 feet above the ground. On the level plateau supporting the tower, there is a rock known to be 500 feet. Okay, here we're using angle of depression. So let's get our tower here. Again, I am not a good drawer, so this will be as basic as you can get. And then, so we have this distance here. He knows that his eye, that this distance right here is 86 feet. He knows that this rock that's right here, rock, is 500 feet from the tower. And we want to know the angle of depression. Well, the angle of depression is, it's from the horizontal down. So the angle of depression is this. That's what we're looking for. But like we said up top, the angle of depression and the angle of elevation are congruent. So if we don't know what this is, but we know it's the same as this. Okay, we know that because of parallel lines, and these become alternate interior angles because the horizontal line here and the horizontal line there both have a slope of 0. So we know that from an old unit. So now I'm going to go into my problem and I'm going to label O, A, and H. From this angle, this is the opposite, this is the adjacent, this is the hypotenuse. And so I'm going to be able to say that the tangent of x equals 86 over 500. Now, anytime we're looking for the angle, we're going to use the inverse function. So shift tangent 86 fraction button 500 and hit enter, and the answer is 9.759. Let's check our directions here. Round angles to the nearest degree. So angles to the nearest degree, that would round up to 10. So the answer is x equals 10 degrees. Let's take a look at number 3. A lighthouse, too far. A lighthouse casts a 30-meter shadow. So let me draw my lighthouse. Beautiful. A 30-meter shadow. So my shadow is down here, and that's 30. When the angle of elevation of the sun, up here, is 36 degrees. Okay? Again, my drawings are terrible, but it's enough for me to look at it. I could use straight lines, and you can use a ruler and stuff like that if you want. We want to know how tall is the lighthouse, so we want to know that height right there. So, tangent, again, you'll notice in these problems there's lots of tangent problems. This is opposite, this is adjacent, this is hypotenuse. We're only going to use the opposite adjacent, so we have the tangent of 36 equals h over 30. Right back into my calculator, the tangent of 36 times 30 is 21.8. So h equals 21.8 meters. That's it for the first 3. These problems, some of you are ready to stop watching the video and just do these problems on your own. That's fine. A cliff is 90 meters above the sea. So here's our cliff, and that's 90. And there's the sea. And then there's a boat. Look at that artwork. And the angle of depression of the boat is 46 degrees from the cliff. So here's our triangle. Remember, the angle of depression is always, it's not here, it's a horizontal line compared to the line of sight. So that's 46, which means this is 46. How far is the boat from the base of the cliff? That's this down here. We want to know that. So when we label, we get opposite, adjacent, hypotenuse. Let's move all this up a little bit so we can see. So we have, again, tangent. The tangent of 46 equals 90 over x. Now here we have the variable on the bottom. You'll remember that when we had the variable on the bottom, x is going to equal 90 divided by the tangent of 46. If you watched the Getting Triggy with It video that I liked on my YouTube channel, they explain to you that when the variable's on the bottom, you just switch places. So 90 divided by the tangent of 46, and we get 86.9. So x is 86.9 meters. Let's take a look at number 5. A 90-foot escalator rises 28 feet vertically. So we have an escalator. Beautiful. All right. And the escalator itself, it says, is 90 feet, and it rises 28 feet vertically. What is the angle that the escalator makes with the floor? So that would be the angle of elevation. So let's label what we got. This is the opposite, this is the hypotenuse, and this is the adjacent. So now we have sine because of SOHCAHTOA. We have sine. So the sine of x is 28 over 90. We're looking for the angle here, so we're going to use the inverse function. Inverse of sine is 28 over 90. Oops. And that is 18 degrees. So x equals 18 degrees. I'm working very hard on making sure I get all my units in there. Miss Ottinger is a stickler for that, and I know, so if you have her, you got to make sure you put units in there. I'm working hard to be more and more like her every day, so the units are important. Just a little piece of trivia as we set up this next problem with another cliff 27 meters high. This is the first video I've made from my house. So Michaela's here helping everybody learn math. Michaela, say hi to the students.
Hello.
There's Michaela. she's learning trigonometry. She'll be the only first grader to have an idea of what trigonometry is. So she's way ahead of a lot of people. A person on the cliff sights a steamer. So we got a person up here. All right, so there's this person who evidently has 4 arms. Sights a steamer, like a steamboat. So let's draw a steamboat. Look at that steam. It's beautiful. Either that steam or that boat's on fire. All right, and it's an angle of depression of 4 degrees. So we go all the way out here to the boat, and this angle here is 4. And there's the ocean. And if that's 4, this is 4. And the question is, find the distance between the steamer and the person standing on the cliff. Now, that's not the distance of the water. That's this distance here. It's the hypotenuse. That's what we're looking for. So when we label what we have here, we have opposite, hypotenuse, and adjacent. So we're going to use sine. So the sine of 4 equals 27 over x. All right. Variable on the bottom again. So we're going to do 27 divided by the sine of 4. And we get 387.1. So 387.1 meters. All right. Kayla's taking diligent notes because she has nothing else to do today. A person is standing 98 feet from the base of the Washington Monument. So the big pencil. That's what we call it in our house. So there's a person. Yes, she thinks I'm hilarious. The person is standing 98 feet from that. And the angle of elevation to the top is 80 degrees. So then how high is the monument? We want to know the height of the monument. So let's label hypotenuse, opposite, adjacent, tangent. So the tangent of 80 is the height over 98. Let's go. Tangent of 80 times 98 is 555.8. 555.8 feet. All right. Technical difficulties. There it is. We need that guy. All right, and we're back. A helicopter is hovering 100. Let's start over. Reading sometimes is hard. Let me take a little. I got a nice cup of tea here. It's good tea. All right, the helicopter is up. Shh, the kids are learning. The helicopter is hovering 100 over a landing pad, 100 meters from where you are standing. So, you. And there's the landing pad. And let's see my helicopter drawing skills. That looks nothing like a helicopter, but we're all going to agree that that's a helicopter. So the angle of elevation is 12. It's 100 meters over the pad. The landing pad is 100 meters from where you are standing, and we want to know the altitude of the helicopter. So hypotenuse, adjacent, opposite, this is tangent. The tangent is, the tangent of 12 is, we want to know the altitude here, so that's A for altitude over 100. So the tangent of 12 times 100. 21.3. Some of us would benefit from going online and checking out a video or two on how to round correctly. Some of the rounding mistakes that we're making are going to cost you answers on the SOL or PSAT or SAT if it's a fill-in-the-blank question. You are flying a kite and have let out 100 meters of string. So here you are. Here's your kite. And there's 80 meters of string. The angle of elevation with the ground is 40 degrees. If the string is stretched straight, how high is the kite above the ground? So the height there, and this is 40. So let's label what we got. This is opposite. Hypotenuse and adjacent, this is sine. The sine of 40 is the height over 80. Alright, so in our calculator, sine of 40, pay no attention to the loud noises, times 80 is 51.4. So the height is 51.4 meters. Last one, a 15-meter pole is leaning against the wall. So here's the wall, here's the pole. Let's put the ground down here. So a 15-meter pole is leaning against the wall. The foot of the pole is 10 meters from the wall. So the foot of the pole is down here. Find the measure of the angle the pole makes with the ground. So we're looking for that. When we label everything, this is opposite, hypotenuse, and adjacent. So this is cosine. The cosine of x is 10 over 15. Anytime we're looking for the angle, we use the inverse function. So 10 over 15 is 48 degrees. And that's it. There's those 10 problems done. You should do 7D on your own. You should be ready for the quiz, which we have next class. I'm really happy we got to do this from my house because nothing says fun like trigonometry in your dining room. Have a great time doing 7D, and remember to wear your seatbelts. See ya.